Welcome to part 3. In this part, we will get familiar with package import and export in OSGI bundles. After listening to this part, you should be able to describe how the package import and export is organized in OSGI bundles, embed an external jar files into a bundle. In the previous part, we stopped at examining the manifest MF file of the bundle jar in the default AEM project. Let's continue looking at the manifest file. So for that, I need to reformat the content of the file because the plugin wraps the lines at 70 characters, so I have rearranged it here in Notepad. Please note two properties: export package and import package. Let's focus on them for now. In those properties, the values are comma separated. I have inserted the line breaks to make them more readable. Export package property lists the packages that are visible outside their dependencies and version. Import packages list the packages imported by the bundle. In export package, each entry consists of three parts: package name, users element, and version element. With default settings, all the packages present in the bundle are exported and are listed here. Now, this is the package name and users element list the packages whose classes are present in public method, public variables, and num OSGI annotations of the class in the package. For example, the filter package. If we look at in the IDE, so this filter package contains one class of login filter, and this class contains public method. In the declaration of public method, several classes are used that all belongs to Java X Servlet package. So as you see here, the Java it belongs to the Java X Servlet package. Let's switch back to our manifest.mf file. Now, about the purpose of this users element, it is required to enable more detailed dependence resolution so that if the consumer wants to use some specific package, the consumer only needs to have dependencies used by this package and not by the whole bundle. And I don't think you will need to use that in real AEM project. Now about the version element. The version element is the version of package. Please note that in OSGI bundle have the version and the packages also have version. In most cases it is the same number, and this number is taken from the version element in the POM file, but that can be overridden. Now about the import package property. The property that lists the packages that are imported that used by the bundle, and imported packages also have the version. When export packages, it lists the exact version as you see over here. But when importing package, in most cases, it lists the version range, and the format of this range is the same as a Maven from some version and to some version. And a square bracket is including a version, and parenthesis means excluding the version. So here what it says is import this package and version must be from version 2.3, including version 2.3 itself to version 3 excluding. So here for example 2.3 is okay, 2.4 is also okay, 2.3 sorry 2.9.99 is also okay. 3.0 is not okay. So let's switch back to our presentation. Let's see how Maven plugin generates those properties. By default, the plugin makes all the packages in the bundle exported with two exceptions. The packages whose name are impl or internal. Those packages are not exported in remain private to the bundle. For the exported packages, it determines the dependencies and places them in users element as we saw in login filter. To determine the version of the exported package, it uses the package info class. If the package info is not present, it uses the Maven project version as the package version. The plugin formats the version in the major, minor, micro format. The plugin determines the imported package by analyzing the class imports and manifest files of the libraries. The version ranges created from the version number truncated to the minor version inclusive to the next major version number exclusive. Let's take a look. So let me get back to the IDE, and please note that the classes in the bundle uses SLF4J for the login. Check dependency in pom.xml, and we see that the version of SLF4J is 1.7.21. Now let's get to our manifest MF. So we see that this package is mentioned in the import package property and the version is converted to range. So 1.7 is gotten by truncating the micro version number by removing that 0.21. And the version 2 is the next major version after 1, so that's why it is used. Now let's play some more with it. Let's add the new package to the project and see what it will be generated. Now I will be going to create one package called stringgen. Okay, and let's copy paste this package info.java into our stringgen package, and this package info java is having version 1.0. Let's change that to 1.1.0, and also I will be going to create one simple class which will be generating a simple string, generate string, and which is having one public method, generate string, which simply returns version of the string, that is 1.1.0. Let's save. Also, let me create one more package. If you remember, the special name of that package is impl, and let me also copy paste this class into the impl, and we will be going to change this version over here, that will be impl, and let's deploy this project now. So it is done. Let me switch to this OSGI console and search the keyword the training. Here it is, and we see that this package of string generator is listed into the exported package, and we see that the version of this package is unlike different than the other packages which mentioned in the exported packages. So that is because the version which we have already specified here in package info.java, that is 1.1.0. And also let's look into this impl package. This impl package is not public by default, and which is having the string generator class, and that is not present in the exported package. Sometimes developers need to override the default logic and customize the bundle properties manually. That can be done using the plugin configuration instructions. We are currently on the package level, so we are interested in the instructions that exports and imports the packages. The names of the instructions are pretty much self-explanatory. That is, export packages is used to override the exported packages, the list of the packages, their properties such as used imports and versions. Also, one can use the exclamation mark to instruct not to import the package, and one can use wildcard to export several packages. Private package instruction is used to list the packages that are not exported. And note that the Maven property can be used to get list of the private packages. Import packages is for overriding the imported packages. The instruction that you see is added when one creates an AEM project from Maven artifact, and what it says is import JavaX inject version, that is 000, any available version, and declare the rest of the packages. That asterisk declares the rest of the packages using the default logic. The documentation for the configuration instruction is located on the Felix Maven plugin page. It can be easily googled. So let me repeat that. In AEM, it is not possible to have multiple versions of the same bundle, but it is possible to have multiple versions of a same package. Now, let's demonstrate this concept. Let's demonstrate the two versions of the same class can coexist in the same OSGI environment. Both versions can be visible to the other bundles, and both versions can be invoked by other bundles. You probably not have to do that in production AEM project. Just see that is possible and can be easily done. For that, we will create a four bundles. Their symbolic names will be different, so AEM will treat them all as separate bundles. Bundle A and B, or core and core 2, will export the same package, but the version number will be different. In the first case, it will be 1.1, and in second case, it will be 2.1. And bundle C will invoke a class from bundle A, and bundle D will invoke the class same class but from bundle B, and we will direct everything from the Groovy console. Let me create one more bundle similar to what we have. In that case, I am just copy pasting core module, and let's say core 2. Let me also delete these other packages than string.gen, and also I am going to delete these test classes and this impl and package info as well. Now we need to change some information in pom.xml of code 2. So let's say code 2. Now we need to embed this code 2 module in apps pom.xml. That we need to embed this. And let's say code 2. And also we need to add the dependency of code 2 module. So that's code 2. Let's change in parent pom.xml. Let's go to, and now let's change the version in string generate string.java. So that is 2.1. And how do we how do we specify the package information here? So previously we used the package info.java, and now let's change the way. I'll be going to copy paste this instruction, that's the export package, in core 2. So here, so that is the package name is stringgen and the version, let's say 2.1. And now let's deploy this project and see. Done. Now let's go to Chrome. And this time we'll go to package dependency or dependency finder, and let's search for our package to package where we replace string generation class and find. Now it says that this package is exported by two bundles, core 1 and core 2. So that was the producer side. Now let's create the consumer side, and let me fast forward. I have created two more modules, two more bundles called core consumer 1 and core consumer 2, and they either of them has a class called string generator version 1 consumer, and those classes have method called invoke generator that creates an instance of string generator called the generate string method and return its value. So, and here it is the same, the method is the same, but difference is that in this case, in the dependency, that is core module, and in core consumer 2, the dependency, that is core 2 module. So this is the only difference. Now let me deploy this project and we will see what happens. Done. Now let's go to the bundle console and see that all bundles are in place. So I have searched the training keyword, and now you see the core 2, consumer 1 and consumer 2. These four bundles are in active states, and now we need to invoke those consumers somehow, and we are going to use the Groovy console for that. So let me paste the following code. Here we import these consumer class 1 and consumer class 2, and for either class we invoke this invoke generator method. Let me remind that what okay, let me switch back to presentation. So let me remind what we are doing So we invoke this consumer bundle, and it in turns invoke this core string generator, and this will invoke the other string generator. So let's execute the script. So as you see, uh, it prints out generator string, and in the first case it is version 1.1, and then in the second case it is version 2.1, and that means there are two versions of one class in the AEM OSGI environment, and those two versions are available at the same time, and they can be used at the same time. Now, can we invoke that string generator class directly? Let's try to do this. So let me paste the following code, the string generator itself, and then prints out the string that generates, and I wonder which version it shows. So this is code. So here I see it's the version 2.1. So I'm not sure how it works. What we discussed so far, it was about packaging the project classes in bundles. It is sometimes needed to deploy a third-party library as a bundle. How do we do that? First, one should make sure that the library is not already present in the AEM. That can be done using the dependency finder. There can also be a ready-to-use bundle with the library already available in the internet. If it is not available, the solution will be to embed, that is, place the library in your bundle. And there are two options here. You either embed the library to use inside the bundle internally. In that case, use the embed instructions as shown on the slide. Or you may want to export the library to other modules. In that case, you need to use the embed instructions, but also add export content instruction and list the packages to export, probably with the proper version numbers. Let me demonstrate that. We will add an old library called Apache Commons DButil to one of the bundle and make it available in AEM. First, let's check the library is not already available in the AEM. For that, let's Google for the command dbutils. And looks like there is some Java doc, so get that package name. Go to the dependency finder, and here uh, put this package name and search for it, and it says that no exporting bundles found. That means that this library is not exported by any bundle. Now let me Google for dbutils maven dependency. So there is dependency. This is the dependency. Let's add this following to the core module. Let's add the following instruction in the Maven plugin, Maven bundle plugin. That's this one. Now let's build and deploy the project. Done. Now let's get back to the dependency finder and search for this package. Now it says that this package is exported by our core module. Now to summarize, Maven bundle plugin automatically determines the package that are exported and imported by the bundle. One can override the default build logic using Maven bundle plugins configuration instructions. It is possible to export multiple versions of the same package in AEM. One can use package dependencies or the dependency finder console to check whether a specific package is exported and by what bundle. It is possible to embed third-party library in bundles. Thank you for your attention. In the next part, we will get familiar with the bundle lifecycle.